Hello, and welcome to Devin's Workshop. Today, I'll be doing part two. I just have a little bit of time here, so I'm just going to quickly go over how I hacked together this RGB LED candle. So there is a part one of getting all of this stuff together. Let's see if I can take this kind of apart here so you can see. So here is a power switch, and that goes to I'm guessing that's enable and ground, 3v3 and enable. And the black wire is on 3v. Nope, that's not it. It goes over here. And I can't see the label over there. So it goes over there. I have a wiring diagram, so I already figured this out. I'll show you the wiring diagram in a little bit. But that is basically what the candle, it's just a 4-pin RGB LED. Nothing special about it. It's got 3 legs. Let me do a manual focus here. So it's got 3 legs, which all go. Yeah, it's hard to see because of the mess of the wiring. There's really no good way to show that. There we go. So it's kind of a mess, but the reason that I wanted to use solid hookup wire is because it's supposed to fit in there. So with the thicker hookup wire, it allows it to be, somewhat sturdy instead of like floppy, braided wire or thin. I should say thinner wire. So this is a thicker wire to make it nice and sturdy. And you don't want these legs to touch, right? Like that, you probably cause a short. So there is a possibility for a short. I didn't use heat shrink or anything like that, which I probably should have. But this was still kind of the prototyping phase, so I might go back and do that. Although it's really unnecessary. So this LED just basically fits inside of that little hole, and again, these were purchased from Amazon, so you could 3D print something like this, probably no problem. So this gets hacked up and slotted into there. Now I have a really large battery in here, but normally I would probably use, something a little bit smaller, like this, so that could fit like right inside of here somehow. But right now I'm just using this to power it for a long time. This is a 2500 milliamp battery, and this will power this for about 4 days continuously on. So that just kind of fits right on top of that. And then you can plug in your plug. I have a magnetic one, so it just kind of pops on there, kind of thing. And then, I didn't even get out my tablet. Automation. Okay, so we're opening the Bluefruit Connect app. Maybe I should turn that off. Yeah, that kind of seems better. Okay, so once you have your BLE code, which I will go over at the end, this is just to demonstrate the capability of the BLE candle. So the ItsyBitsy itself has an NRF52840 chip in it, which is BLE compatible with the Adafruit Bluefruit Connect app. So we go over here, we can see that the ItsyBitsy is online. It says CircuitPy C510. So I hit connect, connecting, this will automatically run through a set of pre-programmed things that I've already programmed it to do on Connect kind of thing. So instead of NeoPixels, we're going to go to Controller, because I have this set up as a controller. And we can go to Color Pad, and we can select a pre-select. One is flicker. So that's a pretty nice, like realistic looking kind of flicker that I programmed, just using random integers. So there's a lower level integer and a higher level integer, and it just randomly chooses a value between the low and high. And it kind of gives a, a flickering flame effect. I think it looks pretty good. So I think I did a pretty good job on that. Let's see. 2 is a pulse. And right now I don't have a color to choose from. In the future you could, if you wanted to, modify the code to pulse in whatever color that you want. But right now it's just pulsing in from 0 to 255 in all colors, which ends up coming out looking white. Because if you go high on all colors, all three are red, green, and blue together, it produces white. And that's how you get white, is 255 on RG and B. And then it pulses down to 0 on RG and B in order to fade to black kind of thing. And then we have, I gotta get that going. Now I have a rainbow cycle. Thanks to Ventru on the Adafruit Discord that helped me figure out the code for this. It was a little out of my ballpark, but got it done. And this is a PWM. This is not like an I2C NeoPixel fade. This is purely in PWM, RG and B, all pulsing at the same time to create a rainbow cycle. It's a little bit more difficult to do than using NeoPixels or I2C addressing. But it is possible, as you can see. And it looks pretty cool. And then 4 should be, if I can get it set at just the right thing. There we go, a solid color. And then once you have it on solid color, you can go back, use a color picker, and then send that color picker value so you can set it to whatever color you want. And that's basically the RGB BLE candle. And now let's go over some code. I'll show you how I coded that up in Mu, because Mu is the default. Okay, here's cursor. Okay, so this is running on an ItsyBitsy NRF to 52840 with the Bluefruit Connect app and a battery, so it's a rechargeable RGB BLE. This really should say BLE. BLE LED candle. So if you're an absolute beginner, I guess I'll go over some of the basics of it. Import time is just so that you have access to sleep timers, which is like a pause, so that you can pause things using time. Board is the ItsyBitsy board itself, and that also imports all board definitions. Digital I/O is required for the digital, in-out pins. PWM I/O is required for the PWM pulsing. Rainbow I/O for the color wheel. And then a whole bunch of Adafruit BLE stuff. This is the main Adafruit BLE library that we'll be using with the NRF 52840, as well as specific classes that you'd want to import for something like this, such as BLE advertising of the device, the services, specific Nordic, this is an NRF, and all of these BLE classes are just standard from the Adafruit Learn Guides. Like, I did not do anything special with any of these. So that's your basic Adafruit BLE import. Here we are prepping the status of the LEDs, which this is really an initialization of digital I/O. So I could word that a little bit better. This is using digital I/O initializations. And this is for the onboard LED, which I don't even think I got into. When you're connecting to BLE, on the bottom of the candle will blink an onboard LED. Yeah, I'm not going to show that. But anyway, it's on the bottom of the candle. It's the onboard LED. It's not a NeoPixel. It's just a little LED. And that way you can control the status messages of connecting. Are you connected? Has it disconnected? You know, that kind of thing. And that is independent of the actual RGB LED, which is initialized here on pin A0, A1, and A2 on the ItsyBitsy, which represents the red LED leg, green LED leg, and blue LED leg. And this is using a common anode type LED. So the fourth leg would end up going to ground instead of power. A common cathode would end up with all four of these going to pins, and then the fourth pin would go to 3 volts or 3.3 volts. In this case, it's going to ground. And then the power is distributed using pins A0, A1, and A2 individually. So that's how we can control individual RGB. And then we put it in a list so that we can cycle through for some functions later. Gamma, I'm not even using gamma. I'm not worried about gamma right now. Actually, I don't really have a lot of time to go over this, but I'll try and be quick. BLE is initializing the BLE radio service, UART service, advertising, all of that stuff is standard, you know, just copy and paste kind of thing from Adafruit Learn Guides. This is where we start getting into the RGB cycles. This is for the solid color, and I've named them all, you know, really easily. Constraint I'm not using. I will probably have to go in and clean a lot of this up, so please don't copy this like word for word kind of thing. Some of these functions I'm not using, that I took from a different Adafruit BLE Learn Guide that had, you know, audio react, which would be cool. You know, maybe I'll do that in the future, and I'll use these kind of, you know, floor ceiling constraint values for audio stuff, but I'm not using that right now. This is for random low and high variables so that we can cycle through 0 to 255 for random values. Now the flicker, I'm using random ints, a low and high value of random ints. So there's a random low to random low, and then a random high to random high, and then a random uniform. So the random uniform is a little bit different than the random integer. I'm not going to go into it. You can look it up in the Learn Docs. I honestly don't have time. I have to go through this real quick. Basically, what we're doing is we are cycling, you know, random values from 0 to whatever this value is, and then picking that back up after that value into another random. So we have a random low between these values and a random high between this value. So it will cycle anywhere the low for the, you know, the kind of off pulse will cycle between this value and this value, and then the high pulse, when it's glowing, will cycle between this value and that value. So you kind of get a random low flicker and a random, you know, high glow pulse, and that's basically how that works. It's basically just two random integers. Oh, the sleep time, yeah, and it's a random sleep. So anywhere between these two values, it will sleep in between the flicker. So this random sleep is what actually causes kind of the flicker of it being off for an unspecified time. And I just came up with these variables from testing. You know, I don't even know what you call it, just trial and error. There you go. Rainbow fade. This is the one that Ventru helped out with. Which is like this kind of thing. I have no idea like how that even works, but that's really cool looking code. So the full range is greater than 8. I think these have to do with the Yeah, the for I loop. So these are random values within the for loop. Uh, red fade, green fade. If you're going to, oh yeah, another thing with the duty, with PWM, the the color is controlled via duty cycle. So it's either 0 for off, or with this, calculation, and it's actually this number 65535 is full on, which is 3.3 volts, and then 0 is 0 volts. But in order to get it into a 0 to 255 value for use with easier integration with other RGB libraries, which are usually 0 to 255, then you do this math, and it will spit out a value between 0 to 255 while also correlating 0 to 3.3 volts. And that's all done with duty cycle. So we have now, with this formula, a 0 to 255 duty cycle, which represents on to full on, or off to full on. And then we cycle these pins. Pin 0, 1, and 2 represent R, G, and B. And that fades through the rainbow wheel. Uh, it's it's easier to write this stuff than it is to explain it. This change speed I don't have. The animate is the different modes. Oh, I gotta go. So yeah, that's it. So I hope that helps. This library will, or this example will be in my GitHub. Yep.